Do you like to get some ice cream when it's hot outside? At least we do. But no one likes ice cream full of large, crunchy ice crystals. That kind of ice growth doesn't just ruin desserts, it can also damage the biological systems and materials. These large ice crystals are formed through a process called recrystallization, which implies that smaller ice crystals merge themselves to form larger ones. Luckily, there's a way to slow down this process using something called ice recrystallization inhibition, or IRI. It refers to how certain substances can keep ice crystals small by preventing them from merging and growing during freezing. Research into IRI is still actively ongoing, as it depends on many different measurement conditions. In this experiment, we focus on one key factor, the gap distance. Accurately controlling the gap distance in thin film assays is essential for reliable IRI experiments. To achieve consistent and reproducible spacing between two parallel plates, we experimented with microspheres made of polystyrene as precision spacers. So, let's start with how to do the experiment. First, get a microscope slide and a coffee glass and clean them both using ethanol. Then, place consistent volume of your microsphere sample onto the slide. Gently lower the coffee glass onto the sample to avoid trapping any air bubbles. Next, apply consistent force to compress the sample. In our experiment, we used a heavy metal bar balanced on a sideways placed metal slab to distribute the force evenly. This is then done over the same predetermined time period for all measurements. This pushes the coffee glass down, flattening the beads and turning them slightly elliptical. Because of this compression, the distance between the plates now roughly matches the diameter of the beads. Now, a laser is going to be used to measure the distance between the two glass plates. Shine the laser through the sample and gently move it around to check whether the measurement is consistent throughout. That's one sample done, but to get reliable data, you will need to repeat this process with different bead sizes, concentrations, or if you're feeling really adventurous, force levels. So you start taking measurement after measurement, collecting more and more data in search of meaningful results. But before you know it, you've used so many samples that you ended just like us. It's something like this.